Namaste, this is Maulya studying in Sri Venkateshwara College of Engineering from Artificial Intelligence Department. Today I am gonna discuss about ARM interrupts and exception concept under the subject microcontroller and embedded systems. Today's agenda, we're gonna start with introduction to the topics exception and interrupts. We're gonna know the difference between exception and interrupts, importance of exception and interrupts in microcontroller system, ARM exception categories, the exception vector table, ARM interrupts and various types, exception and interrupt examples. Moving on to the actual concepts, ARM exception and ARM interrupts. First, let us understand what ARM stands for. ARM stands for Advanced RISC Machines, and ARM architecture, it gives us an idea or approach of how hardware of a system is designed and how it's different from the other familiar architectures. So coming to the topic ARM exception, exceptions are an synchronous events. Synchronous event is nothing but the memory is transformed in the form of a blocks or frames, and exception is an event that occurs as a result of execution of a program. And when the exception is triggered, the processor, it temporarily stops the ongoing program and shifts to the other execution mode to handle that exception. So exceptions are typically caused by events like page faults, undefined instructions, and software interrupts and data aborts, as you can see in the slide. And next comes the ARM interrupts, and ARM interrupts on the other side, they are asynchronous events, which means the data has been sent either in a form of a character or a byte, and here it occurs externally to the processor, and typically interrupts are used to signal the external device which needs the immediate attention. Now you can see the role of a processor, which differs from ARM exception to ARM interrupts. In ARM exception, the processor, it usually temporarily stops the ongoing programs and shifts to the other execution mode. But in ARM interrupts, the processor, it usually suspends the ongoing program, it saves the context and jumps to the specific interrupt handler routine that is associated with the interrupt source. Now let us see the difference between exception and interrupts. Exception are triggered directly by a processor itself, and it is a response to the specific conditions that has been encountered during the execution of an instruction or a program. For example, let us take a data abort exception, and it is raised if the processor tries to access the wrong or a invalid memory address. Coming to the interrupts are generated externally to the processor by a peripheral hardware or devices. When a peripheral generates an interrupt, it sends a signal to the processor so it can take a immediate attention. Coming back to the exception, when the exception occurs, the processor usually saves the context of the ongoing current execution, and then it moves to the corresponding exception handle. So after the exception has been resolved, it has the option to either return back to the normal execution or continue with the ongoing execution process. Coming to the interrupts, when an interrupt is triggered, the processor saves the current ongoing execution and jumps to the corresponding interrupt handles routine. After handling that interrupt, it usually come back to the original execution context and resume the interrupted task. So why exceptions are used? Exceptions are used to resolve the errors we usually get in the executions. So unexpected events and special process specific instructions are everything being resolved by an exception. And why interrupts are used? Interrupts are commonly used for real-time processing and handling time critical events. So let us take an example of time interrupt, which is generally used to trigger a time sensitive operations. So coming back to the exception usually it has a predefined priority, and the processor typically handles them in a fixed order based on their priorities. So in interrupts, it usually many interrupts can be handled simultaneously by the processor. Why? Because interrupts can have different priority levels, and the processor it usually handles them according to their priority. So let us know the importance of exception and interrupts in microcontroller system. Usually exception and interrupts play a very crucial role in microcontroller. So, because they enable efficient responsive handling and various events and tasks in embedded system. So here you can see some key reasons why exceptions and interrupts are essential in microcontroller architecture. So first one is real-time responsiveness. Usually interrupts it allows microcontroller to respond promptly to the external devices and to stimulus themselves to the external environment, such as sensor reading, communication signals, or time sensitive tasks, etc. And next comes the error and exception handling. Usually the operation it experience many errors. The microcontrollers experience many errors during the operation or execution process. So this exception it provide a mean to gracefully handle these errors, be it preventing the crashes or anything else. So it exception handles can log the errors, reset the microcontroller, and in short it clears the errors and make it easy for a microcontroller to take the operation or the execution process forward. So next comes the multitasking and multi-threading. With the help of interrupts, microcontrollers can perform multitasking and multi-threading capabilities. The processor it can usually shift between the tasks based on their priorities, and allowing the system to effectively manage the multiple processes simultaneously. And next comes the power management. So exception and interrupts it gives on many strategies for power management. We have heard about a low power mode. So when the exceptions are not triggered or not occurred yet, the microcontroller it goes to low power mode and it wake up only when the exceptions are occurred. So in this way the battery life can be prolonged and the power management occurs, and this is the application of a battery power mode. So here we can see the ARM exception categories. In ARM architecture, the exception can be categorized into two main groups. Those are synchronous and asynchronous. In synchronous, data is being transformed in the form of a blocks or frames, but in asynchronous, the data is being transformed in the form of a character or bytes. In synchronous exception, we can see a data abort, which means when the processor tries to access a memory location that results in memory access violation, such as accessing a invalid address or attempting to read from write-only memory. Next comes a prefetch abort. It happens when the processor it encounters an invalid memory address which is out of a memory space. Next comes a supervisor call SVC, that is software interrupt instruction that allows program to switch to privileged mode to perform a privileged task. Next comes the asynchronous exception. Asynchronous exception is also known as interrupts, as we discussed in the previous slides. These are the events that occurs externally to the normal instruction flow when an asynchronous exception is triggered. These exceptions are asynchronous because they are not directly caused by the instruction being executed. They are caused by the external devices or external peripheral devices. External interrupts generated by external devices or hardware peripheral such as timer or general purpose input and output. Next comes the timer interrupts, often used in time making or time generating tasks generated by a time to trigger. Communication interrupts, it is used in communication protocols like UART and SPI. Let us discuss about the exception vector table in this slide. Here you can observe the exception vector, vector address and modes in this table. So the exception vector table EVT is also known as interrupt vector table IVT, or a simple vector table. It is a data structure used in a microcontroller as well as in a processor to manage the exception and interrupt handlings which we discussed in our previous slides. The EVT is typically programmed during the microcontroller's initialization, and the address of the handler routines are set based on the specific requirement of the applications. It is very crucially and it is very important to correctly set up this exception vector table to ensure that the exception and interrupt handlings are made correctly or handled efficiently and accurately in the microcontroller system. In previous slides, we have got to know many important aspects of exception and interrupts and how they are useful and how important it is for the microcontrollers. Now let us know how exception and interrupts are involved in our daily lives. So in industrial automation, in robotics, in real-time operating system, and even in the medical devices, exception and interrupts play a very important role. Now let us discuss how it is helpful. So in industrial automation system, microcontrollers with interrupts are used to handle various events and sensory inputs. In industrial automation, there will be a need of a temperature check or actuators, motors, and devices with minimal latency, ensuring precise and timely control of industrial process. Everything is very important. So here the interrupts, it plays a very important role. And next comes the robotics. In robotics, it is very important to maintain the precise position and orientation of the robot. So interrupts are commonly used to handle the sensor inputs, motor control, and communication with the other devices. We have been discussing that interrupts usually it communicate with the external devices. So the peripheral hardware, so the external device, it sends a signal to the processor to get that immediate attention. So in here also interrupts, it handles the sensor inputs and the motor control. So for example, we can see that interrupt driven routine can process data from the encoders or inertial sensor to maintain the precise position and orientation of the robot as told earlier. So next comes the real-time operating system. Real-time operating often utilize exception and interrupt to both to manage the tasks scheduling and context switching, etc. When the higher priority tasks become available or when the interrupt occurs, the RTOS switches to the context effectively using interrupts, so allowing it to quickly respond to the critical event while maintaining the strict time constraint for real-time task. And next comes a very important aspect of a human life, that is a medical devices. And in medical devices, especially life supporting system, real-time operating system plays a very crucial role, and exception and interrupts are used to respond to the input from the sensor monitoring vital signs, heartbeats, flow of blood inside our body, be it a breathing rate, etc. So, and ensure the proper function of the medical equipments, immediate response to the critical condition. It can be very useful and can be life-saving in a medical applications. So let's summarize what we have learned in this presentation. So ARM exceptions, they are synchronous event and it occurs as a result of executing an instruction, while ARM interrupts are asynchronous events triggered externally by a processor, and it creates a stimulus within the external environment, and the peripheral hardware and the devices, it sends signals to the processor for the immediate attention. So both mechanisms provide ways to handle events that require special attention and enable the processor to switch between different execution contexts to handle this very effectively. So the exception and interrupts are essential features we have known even in the real-time operating system, be it medical devices, industrial automation, robotics, etc. Everywhere exception and interrupts have been very crucial role. It enables them to efficiently handle events, manage resources, and respond in real time to external stimuli. These mechanisms are fundamental of creating responsive, energy efficient, and reliable embedded system across various applications. Thank you so much for listening. Please do like the video. Thank you.